So we're going to start looking at section 4.1 today. It's our last section for the week, and we'll finish it tomorrow. So we talked yesterday a little bit about scatter plots and how you can draw a line that goes through the points. And the way that we did it was just by eye. You know, we did it the best we could. And we're going to talk about today when you draw in a line, how good of a line is it? So if I go back to what we did in the warm-up, that's a pretty good line. Okay? And the way I can tell it's a good line is if I look at the dots and I look at how far each dot is from the line. In general, each dot isn't really that far. If I drew a line, you know, maybe like this, I would say that that's not a good line. Because if I start measuring all these distances, like from this dot to my line, and that dot, there's quite a distance, right? And we're going to talk about measuring those distances today, and that's going to tell us how good the line is. Okay, the smaller the distance, the better the line is, because that means the dot is really close to it. So on your guided notes, the first blank is going to tell us what is that distance called. Okay? And that distance for how far away a dot is from the line is called a residual. Okay? A residual is the distance between the dot and the line that you drew. And ideally, you want that to be as small as possible. Okay, and here's the picture that's on your guided notes. So on the first blank, you'll fill in the word residual is the difference of the y value for the data point and the y value on your line. Okay. So what do we mean? Here's your data point. That's was given to you. Maybe that would have been given to you in a table. And here's where the point would be with the line that you drew. How many units away is the actual point from the line that you estimated? 3. Okay, so that's a residual of 3. And because it's above the line, that's called a positive residual. Okay, because it's 3 units above. Now, if we look at this one, here's the data point from your table. Here's where your line predicts where it should be. What's the distance between this actual point and where the line says it should be? 2. That's a difference of 2. And because the data point is below the line, it's called a negative residual. Ideally, again, we would want this data point closer. You know, if we could fix the line so it would be a little closer, we would try to do that. So any questions on that idea of what a residual is? Just measures the distance between where your point is and where your line predicts it should be. We try to keep it small. So where it says on the next bullet, you guys have a residual can be positive, negative, or 0. It'll be positive if your data point is above that line, negative if it's below, or ideally 0, that's the best. If you had a 0 residual, where do you think that means your data point would be? It'd be right on it. That's what you want. Can't always do that. Like if I go back to this one, I mean, that's, just erase the one that I put in here. Get rid of that one. Let's get rid of those distances. Yeah, that's pretty good. Some of these points have a 0 residual. Those 2 in red look like they're right on it. The next one in black. As we get towards the end, we have a few negative residuals. And then towards the beginning, there were a few positive residuals that were above the line. So we try to keep those balanced out. As many above and below as. Try to keep them the same. All right. Does everybody have those 4 blanks filled in on your guided notes? All right. So how do we figure out how good of a line of fit we have? Okay. So what we're going to do is we're going to make a scatter plot. Okay, just like we did yesterday. This is going to be a scatter plot of how far each point is away from the line. I'm going to show you guys how we do it. So we're going to make a table. And you guys have that table. You have it down in example 1, and we're going to use that when we fill in the graph of the residuals. So on the homework, I'm going to try to make sure, I think I put this already on there for you, so you have the graph paper. Okay, so the table that we're going to make, it's got 4 rows in it. It's got an X and a Y value. Those are going to be given to you. Okay, those are already going to be filled in. The Y value from the model, that's what we're going to have to look at once we draw a line through the data. Okay, and we'll figure that out. Then the residual is going to be when we subtract. Okay, we're going to look at the difference between where the line says the point is and where it actually is. Okay, and we'll subtract, and in this case you get 3. All right, so let's write that down. Okay, so on the first bullet, again, the X and the Y rows, those are going to be given to you. So you won't have to figure anything out for the first 2. Okay, the next row in the table says Y value from the model. So the models we practiced doing in the homework last night. Okay, that's when you're finding an equation. So I'm going to go back to the problem we did, I think it was about the plants in the garden in the homework. Let's see if I can find it. Right here. This is the model. It's not the actual data. It's the equation of the line that we drew the best that we could. Okay, so this is called the model. Y equals 2x. The model has a slope and it has a y-intercept. You have to find both. Okay? If it's not given to you. Sometimes you might be given a model. Okay, so the y value from the model, okay, this row, is the answer that you get when you plug x into the equation that you figured out. Or the equation that was given to you. It might be given to you sometimes. So the y value from the model is the answer that you get when you plug x into the equation that you find. And remember, the equation has a slope and it has a y-intercept. Most of the time, I'm going to try to make the slope and the y-intercept come out to nice numbers, so you don't have to deal with decimals or fractions. Yes?
So the y value is the answer to the y value that we get when we plug into x?
So which one? The y value from the model?
I don't know. I'm confused.
So can you ask your question again?
Why is the y value from the model different from the y value we get when we plug into x?
So there's a y value that's going to be given to you in the problem, and then there's a y value that you're going to get that's being predicted by the line that you draw. And the line isn't always perfect. That's why there's going to be a difference between these two y values, just like in this picture. So this is the real y value. This is the one that is on the line, and the line isn't perfect, so there's a difference of 3 there. That's what we talk about when we talk about the y value from the model. That's where it would end up on the line compared to the actual point they give you in a table.
Okay.
Ideally, they would always be the same, but we can't always draw a line that's perfect. So like in this problem, there's no way that I can draw a line that would go exactly through all those points because they're not in a perfect line. So there's always going to be a little bit of a difference between the actual y value and what the model predicts the y value to be. It's always a little bit of a difference for most of them. And that difference between what the line says it should be and what it actually is, that's called the residual. So to find the residual, you're going to take the answer you got in row 2, and you're going to subtract the answer from row 3. And just so it's clear what I mean by rows 1, 2, and 3, this is row 1, 2, 3, and 4. So row 2 minus row 3. Row 2 minus row 3. Right, and then on the last line right above example 1, this shows you what we're going to graph. So this picture that we're going to make from these steps is going to tell us how good is the line that we drew. If our residuals are really high, probably going to want to go back again and draw a better line. If the residuals are low, that's what you want to happen. Okay, you want the residuals to be very low. And you guys don't have to write that. That's what I just said to you. If your line is a good fit, then the residuals are going to be very small. If the residuals are big, you didn't draw a good line. Okay. Yeah. Okay. Does everybody have what goes on the 4 lines to their guided notes? Yeah. Sure. Right. So let's try an example. So we had this problem yesterday. It was about, I think it was like DVD, like the number of weeks after a movie came out, and then like how many sales the movie had for DVDs. Now we had a slightly different equation. I think we might have had plus 19 or plus 18 here, but I just made the numbers a little bit easier for us to do the math with. I think this was also negative 1.5 yesterday, but I made it negative 2, so it's a little easier. So we figured this model out yesterday. So what I want to do now is analyze how good is that line that we found. Because we drew that line by hand. Was it a good line? Or was it not a good line? Let's see. So I took the data that was in the table and I put it into my table. I think you guys already have that part done. So the next row you have to fill out is the y value from the model. This is the model. It's the formula that predicts what the DVD sales should be. It's not always going to be exact, because no model is perfect, right? But we're going to see how good it is. So it says, plug x into the equation. So let's do that. What's our first x value in that table? 1. We're going to take 1 and we're going to plug it into the equation. And that's going to be what the model predicts what we should get. This is what we actually got. Let's see how close the prediction is. If you plug in 1, what's negative 2 times 1? Negative 2. And what's negative 2 plus 20? 18. So is the prediction close to what the actual value was?
Yeah.
Yeah, that's pretty close. It's not bad. Right, let's do the next one. Plug in 2. What's negative 2 times 2? Negative 4. And what's negative 4 plus 20?
16.
16. So the formula predicted the sales should be 16. The data said that the sales were really 15. Was the prediction close? Yeah, that's pretty close. All right, let's do the next one. Plug in 3. What's negative 2 times 3?
5, 6.
Negative 6. And what's negative 6 plus 20? 14. Okay, again, was the prediction close to the actual value?
Mm-hmm.
Yep. Right, let's plug in 4. What's negative 2 times 4? Negative 8. And then if you add 20 to it?
12.
12. Okay, let's plug in the next x value, 5. What's negative 2 times 5?
Negative 10.
And what's negative 10 plus 20?
10.
10. You might notice a pattern in the y value from the model.
It's going down by 2.
It's going down by 2s. So what's the next value going to be?
8, 6, 4.
4. Okay. Was there any time that the formula predicted the exact value correctly?
Mm-hmm. Yes.
Yeah, one time. Well, 2 times, actually, 2 times. It looks like the formula predicted exactly the right value. All right. So now we're going to find all the residuals. The residual is how far off was the formula each time. Take row 2 and minus row 3. Okay, this is row 2. This is row 3. Okay, what's 19 minus 18?
1.
So that's a residual of 1. What's 15 minus 16?
1. Negative 1.
Negative 1. 13 minus 14?
Negative 1.
Negative 1. Okay, what's the next one?
Negative 1.
Negative 1. The next one?
0.
0. 0 residual is perfect. You can't get any better than that. Right? That's what you want. What's the next one?
0.
0. The next one? 1. And the last one?
1.
1. Okay, so that looks like it's going to be pretty good. So let's graph those residuals and see how good they are. Right. So it says on the last step, the graph is going to be x, comma, residual. That's what we're going to graph right now. So let's go to our table. So x, I'll just highlight it. X are these numbers, and the residuals are those numbers. So we're going to graph x, comma, residual. Okay, so here's the first one. 1, comma, 1. So you're going to take the x value from here and the y value from there. So x, comma, residual. Okay, so x is 1, and the residual is 1. So let's graph that. 1, 1. Okay. The next point, x is 2, and the residual is negative 1. 2, down 1. Okay, what's the next point?
3, negative 1.
3, negative 1. Yep. What's the next point?
4, negative 1.
4, negative 1. Okay, and the next one?
5, 0.
5, 0. Yep. Next one?
6, 0.
6, 0. Okay, the next one?
7, 1.
7, 1. And the last one?
8, 1.
8, 1. So what this graph is showing you is how good your line is. Okay? And what you're looking for is that if your model is a good fit, you should have about the same number of residuals above and below your horizontal line. How many red dots are above the horizontal?
3.
3. How many below?
3.
And you have 2 right on it. You're not going to get much better than that. That's a very even split between points above and points below. So that's what this graph shows you, how good your line is. And that's it. That's how you make a graph of residuals. Now, what a computer or what a calculator can do is it can draw millions of lines in like 1 second and look at the residuals every time it does it and automatically find the best line where these numbers are the smallest. That's what the computer can do. It can make these residuals as small as possible versus doing it by hand when we just do it. We can't really do that, but a computer can. All right. Any question on that? All right, let's try one more. I'm going to let you guys try this one. Okay, so it says the table shows the ages and the salaries of 8 employees at a company. So the age is how old the person is in years, and the salary is in thousands of dollars. So this doesn't mean they made $42. This means they made 42 what? 1,000, 44,000, 51,000. Okay. And you do not have to find the model. They give you the model. What's the model that they give you to use? So what's the formula that they give you that says it should predict the salaries of the people? So I'm looking for a formula.
Y equals 0.2x plus 38.
Right. Okay, we don't know how they figured this out. We don't really care how they figured it out. All we know is that's the formula that's going to model the salaries of this company. Is it going to be perfect? Probably not. This is the actual data. The model hopefully is going to be close. We'll see. Right. So what you have to do is, and I'll get the calculators out. You have to plug in each x value, one at a time, into the model, and we'll just round it. Okay, round it to like the nearest whole number. So like if you get 50.2, just call it 50. If you get 39.9, call it 40. Okay, so we'll round it. All right, so find out what the model predicts the data to come out to, and then see if you can find all the residuals. And then we'll see if this is a good model for the data. Okay, but let me get the calculators. Okay, let's do the first one together just to make sure everyone's on the right track. All right. So what's the first x value that they want you to plug in?
35.
Yep, 35. So you're going to take 35. You're going to fill it in for x and see what you get. So you want to type 0.2. Hit the times button. 35. And then do plus 38. So what did people get for their first y value from the model? Yeah? 45. That is the correct answer. Okay, so if you didn't get 45 for your first one, you made a mistake. Okay. Let's do the second one together. What's the next x value they want you to plug in?
37.
37. So take 37, fill it in. So type 0.2 times 37, and then plus 38 on the end. And if we round that one, what would that round to? Yeah?
What does that say? So is it 45? So
It says 45.4.
so it would be 45.
We're going to round that to 45 because it rounds down. Yep. Okay, let's do one more just so we can actually get a different number. What's the next x value they want me to plug in? 41. So do 0.2 times 41, and then hit plus 38. Okay, what would that one round to?
46.
That one would round to 46. Okay, so keep going till you get those last 5. Right, what's the next x value that they want you to fill in?
43.
Yep, 43. And did anybody get an answer? What was the y value from the model you got for that one?
46.
You also got 46. The next y value is 45. That came out to 47. How about when you plug in 47?
I also got 47.
You got 47?
I don't know if that's right or not.
How about 53?
48.
That one came out to 48. And how about when you plug in 55?
49.
49. Okay, so now the residual is how far off was the model from the actual data. Remember, it's row 2 minus row 3. What's 42 minus 45?
Mr. Saying the last one is not 48, it's 49 because it came out to 48.6.
Oh, it came out to 48.6?
Yeah.
Okay, then that should be 49. Okay, thank you. What's 42 minus 45?
30.
How much?
-3.
Negative 3.
Oh,
So that means that our actual data was 3 units below the model. Okay. How about the next one? What's 44 minus 45?
-1.
That means our actual data was 1 unit below the model. Okay. 47 minus 46?
Oh,
1. 50 minus 46?
3.
2. Sorry, 4.
4. 52 minus 47?
5.
Ooh, this is not good. We're too far away. These residuals are getting high. What's 51 minus 47?
4.
4. 49 minus 49?
0.
Well, that was a good one. So that wasn't bad. And then 45 minus 49?
-4.
Negative 4.
Mister, that one is 47, not 46.
That's okay. We're just going to go with this data. Yeah, at this point, we'll just go with that. Okay, so we've got our data. We've got our residuals. And now you want to graph x, comma, residual. This is going to visually show you how far away your data points are. Okay, so again, just to highlight it, there's x, there's your residuals. Okay, so the first one is 35, negative 3. Okay, so let's do that one. So 35 was negative 3. Okay, what's the next one?
37 -1.
Okay, so 37, just go a little past it, negative 1. Okay, what's the next one?
41 1.
41 was, that value was off by 1. That's what we're graphing. How far off was it? Okay, what's the next one?
43 3.
43, 4.
4.
Should be 43, 4. So 43, that one's way up. So 43, 4. Okay, the next one is 45, 5. So way up there. What's the next one?
47 4.
47, 4. So 47, 4, just estimating. The next one?
3 0.
53, 0. That was a good one. So maybe about right there. And what was the last one?
55 -4.
Yep, so the value for the 55 was off by 4. 1, 2, 3, 4. Okay, so how many residuals were above the line?
4.
4. How many were below?
3.
3. Okay, so it's pretty even split on the residuals. How many were right on the line? 1. Okay, so we have about an equal number above and below, 4 and 3. We have 1 that's right on it, and the highest residual we had was only 5 off. So if we had residuals that were like 20 or 30 off, then I'd say that's pretty bad. But overall, that's pretty good. It's not as good as this one. This one was really good. Okay? The residuals never got more than 1 unit away, up or down. So I would say it's a good fit. It's not a great fit. Okay, so I would say yes, it is a good fit overall. It's not that bad. And the size of your residual is relative to your data. If you're dealing with data in like the billions and you're off by like 20 or 30, that's not a big deal at all. Think about it. If you get data that's in the billions and you're off by 20, that's a really small amount. But if you got data that's in like the 40s and you're off by 20, well, that's a lot. That's a real lot. So the size of the residual is kind of relative to the size of your data. But I would say overall this is pretty good. Okay, so any question on it? All right, so how do you figure out these models without doing it by hand? Like, how do you get 0.2x plus 38? Or how do you get negative 2x plus 20? Well, that's what the calculator can find for us. So the calculator can find those models by putting in the information. So on your guided notes where it says, graphing calculators use a method called, in that first blank, you're going to fill in the word linear regression. And then on the second blank, you're going to fill in line of best fit. So we talked about a line of fit yesterday. This is a line of best fit. It's the best slope and the best y-intercept that the calculator can possibly calculate for you. And the method that the calculator uses to do it is called linear regression. We are not going to learn how you do linear regression by hand. That's a little bit more complicated. We're just going to plug the data in on the calculator, and it's going to do it for us. Okay, so this is going to be the line that is the best line you can possibly do for your data to make the residuals as small as you can. All right, so what I'm going to have you guys do first, just so everybody's is kind of at the same thing, I want you to turn it on. So press the button in the lower left, and you should be at a screen where your cursor is blinking in the upper left. If it has information on it, because somebody typed something in, that's fine. You can press the clear button, which is all the way on the right-hand side below the arrows. You don't have to clear it, but if you want to be at a screen that looks like that. Is anybody not at a screen like that? Yeah.
Mine has like the Y.
The Y. Yeah. So let me help you just a second. Quit, and now you should be at a good screen. Okay. If you get stuck in a screen that you don't ever want to be in, you can always press second, and then the button right next to it is quit, and it'll bring you back. But I can help you get to that screen. All right, is everyone at a screen that looks like that? Okay, so what I'm going to do now is I'm going to have everybody just reset the calculator so then I know everybody's calculator is exactly the same. So press the button in the upper left that says second. And then there's a button, there's a plus sign, and right above it, it says MEM. Press the plus sign. And now you should be at a screen that has those 8 options. Is everybody at a screen with those 8 options? All right. I want you to go and press 7 because 7 is reset. So just on the keypad, just press the number 7. And now you should be at this screen where there are 2 options. You're not going to have to remember how to do this. I just want to do it the first time. And it's quicker to have you all do it than me to do each one at a time. Is everybody at a screen that looks like that?
Yep.
All right. So what we're going to do is we're going to press option 1. And then it's just going to ask us, are you sure? And it just says it's going to erase everything. That's fine. It should say reset RAM. And then we're going to press option 2. Okay, and my screen got a little darker. I don't know, did yours get a little darker too?
Yeah.
Yeah, we can make it brighter again if you want it brighter. If it's fine the way it is, you can leave it. But if you press the blue button and you press the up arrow and you keep going back and forth, the screen will get brighter. It doesn't really matter how bright you have it. I like mine bright so you can see it from your seat easier, but it only will get so bright. As long as you can see the screen, that's fine. Okay, anybody need help getting to that screen?
Sorry, after you brightened your screen, did you push another button? Sorry, it wasn't.
I don't
Thanks.
think so. Nope. Yeah, mine looks just like that. Yep.
Okay. Nothing there?
Yep. You can press clear too. Everything will disappear.
Okay, thank you.
Can you listen to music on this?
No.
Why is it aux port?
For transferring data between calculators.
Wait, what? So it's like Pokemon trading.
Okay. So what we just did is I just had everybody reset the calculator. So now I know everybody's calculator is at the exact same spot and not different. All right. So let me show you how do you put in data on the graphing calculator. So there are pictures on your guided notes to kind of help you remember what it looks like. All right? So it says how to find a line of best fit on your graphing calculator. And you guys, do you have a table under example 3 with numbers already in it?
Yeah.
Perfect. Okay, we're going to use those numbers. So it says the first thing to do is press the button that says stat. Okay, the stat button is 3 over and then 1 down. And it says STAT. Okay, and I'm pointing at it right here. Okay, so press that button. And then the next thing it says to do is go to edit. Well, mine's already on edit. Okay, if it was on something else, I would have to press the arrow and make sure it's on edit. But everybody should have the edit with a black box around it. Is there anyone that doesn't have a black box around the word edit? Okay, so once you're there, is everybody have option 1 highlighted? Like you don't want to have option 2 or 3. You want to have a black box around option 1. Does anybody not have a black box around the 1? Okay, so press enter. And you should be at a screen that looks something like that. That's a little bit different model, but it should have an L1, an L2, and an L3 at the top. Was anybody unable to get to that screen? Eli, you get there? Okay, so stat, and then option 1, hit enter. Okay, anyone else that's not at that screen? Okay, so this is where we're going to type in the information from example 3.
Understand?
Yes.
Press stat, but it still said they want me to this.
So press stat, and then under option 1, hit enter. And it'll take you to that screen. All right, now we're not going to end up using most of these. We're just going to use the first 2. What I want you to do is look at the table in example 3. And I want you to look at all the x values. 1, 2, 3, 4, 5, 6, 7. I want to type those x values in the column that says L1. Okay, so the first column is L1. And now we're going to type in the x values from the table on your guided notes. Okay, what's the first x value they want us to type in? 1. So you type 1, and then you hit enter when you're done typing the number. Yes? Yep, just sign out. Okay, what's the next x value?
2.
2. 2, hit enter. What's the next one?
3.
3, and how high do we have to go?
7.
We got to go all the way to 7. So keep going. 4, 5, 6, 7. Okay. So everyone's calculator should have those 7 numbers under where it says L1. Yes.
How do I like get my extra 3 out?
All right. So if you make a mistake, like let's say you type in the wrong number, like that's supposed to be a 7, I can press the up arrow, highlight it again, and then I can type in a new number, just like that. So if you make a mistake, you don't have to start over. You can just fix the one that you made a mistake on. Okay, does everybody have the numbers 1 through 7 in that L1? Okay, now on your guided notes, what does it say to put in L2? We've got to put some numbers here.
A Y?
The y's. Type all the y values into L2. Okay, well we have to get over to L2. We're still in L1. We need the black box over here. So if you press the right arrow, your black box should move over to the next column. Was anyone unable to get their black box over to the second column? Okay. What's the first y value they want us to type in?
9.
Yep, 9. And then the next one?
5.
5. And we're just going to keep going down. 13. 11. 10. 11. 19. All right, so that's the long part. You're just typing everything in. You'll probably never have more than, I would say, that amount of points to type in. Was anyone unable to get their screen to look just like that? Okay, so now the last thing is we need to tell the calculator what we want it to do. We want the calculator to tell us the slope, and we want the calculator to tell us the y-intercept of the line that goes through those points. All right, so let me show you guys, just watch what I'm doing. You guys don't have to do this. I want to show you what those points look like. 0, 10, and let's go 8, 2, that's the points that you just put in your calculator. You don't have to know how to do that. I just wanted to show you what the points look like. So we're going to try to find a line that maybe, looks something like that goes through those points. Okay? Do these points, are they in a perfect line? No, so we're not going to get a great line, but we might get something, I don't know, kind of like that. 2 points on the line, 2 points above, 2 points below. Maybe it'll be about right there. That's just my estimate. Let's see what the calculator does. So last step. After typing in all your data, press the Stat button again. So everyone should be at a screen now that says Edit, Calc, and Tests at the top. Is anyone unable to get to that screen?
You hit the Stat button again.
Hit the Stat button again. Yep. Okay. And now, press the right arrow. And that's going to go to the second thing at the top that says calc. Okay, press the right arrow. And now it says calc. Now, the calculator can find all kinds of things here with those points. The only thing we want to do is find a line. So there should be an option if you scroll down that looks exactly like what I wrote on the board. Does anyone see what option number on the calculator looks exactly like what's on the board?
4.
Yep, it's option 4. So we can go down to option 4, and you should have a black box around the 4. Does everybody have a black box on the 4? Okay, so now hit enter.
Mine was at number 8.
Okay, well, make sure you go to 4. We want 4. Okay, if you did everything that I did, you don't have to change anything. Okay, I do have to update this one step. So on your guided notes, just cross out that last step and put go to calculate and then hit enter. So go to calculate and hit enter. Calculate is in the bottom. So to get to the bottom, we press the down arrow. We don't have to change anything there. We're not even talking about that other stuff. So is everyone able to get a black box around the word calculate? Okay. Once you get a box around that, hit enter. That is the equation of the line. So let's see what it says. So it's giving us two values. Which letter there do they use for the slope? They use a little different letter than what we do.
A.
They use an A. That's just what it is. So that's your slope. And what letter do they use for the y-intercept? B. Okay, so they use the same one we do. How many people got a slope of, let's call the slope 1.4, and a y-intercept of, let's call it 5.6? How many people got those numbers? You got those? No?
I got 4.1 on the box.
Okay, that's not, let's see, so stat, edit, you got all your points typed in correctly. So stat, help, option 4. All right, one of your points I think is wrong. We'll have to double check. Okay. So from that, what did it say the slope was?
The
1.4. And what did it say the y-intercept was?
5.6.
5.6. Okay, that's the model. Let me type that in. You don't have to type it. Let's just see how good it looks. 1.4x plus 5.6. Okay. What do you think? Does that look pretty good? It's about as good as you're going to get. 3 points above it, 2 points below it. Okay. So we'll practice doing another one of those tomorrow. So what I need you guys to do is help me put the calculators back. So first thing is to turn it off. Press the second button in the upper left, and then press the on button in the lower left. And then the screen should go black. We'll press the second button in the upper left, and then press the on button. Now, on the back of your calculator, there is a number. Make sure you put the number back in the right slot. Thank you. Right? And if you have trouble, don't worry. We're gonna do it again tomorrow. And the homework for tonight is the 4.5 Part 1 worksheet. Okay. If there's a question on the worksheet where you need one of these calculators, we will do it as a warm-up tomorrow. Because you probably don't have one of these calculators at home.
Yeah, just stronger.